Have you ever heated up some water in the microwave only to have it violently erupt the second you touch it? It's a pretty common and honestly a pretty scary kitchen mystery. Well, today, we're going to crack the case of the exploding water. And believe me, the solution is a really cool bit of physics. Let's get right into it. I'm sure you've seen this, right? You pop a mug of water in the microwave, you heat it up, it looks perfectly calm, and then the moment you drop in a tea bag or a spoonful of sugar, boom, it just erupts, splashing scalding hot water everywhere. So what is going on there? Why does perfectly still, calm-looking water suddenly explode like that? Okay, to solve this little mystery, we have to start with the basics. You know, how water normally boils. And the very first clue, you might have guessed, is all about the bubbles. That's right, the humble little bubble is at the absolute heart of this whole thing. And to really understand why, we need to look at this invisible force that's at play on the surface of all liquids. It's a force that makes it surprisingly tough for a bubble to even be born in the first place. And that force has a name, surface tension. The best way to think about it is like this. Imagine the surface of the water is a tightly stretched skin, kind of like a balloon. This skin is constantly pulling inward, and that creates pressure that literally squeezes anything trying to form inside it, including, you guessed it, the bubbles of steam that we need for boiling. So boiling is basically a battle. It's a tug of war. On one side, you've got heat, creating water vapor that wants to push outward and form a bubble. And on the other side, you've got that surface tension squeezing in, trying to crush that bubble before it can even get started. For water to actually boil, the vapor pushing out has to have enough energy to win that fight. Which brings us to this very famous number, 100 degrees Celsius or 212 Fahrenheit. Now, at sea level, this is the magic temperature where the heat finally gives that water vapor enough of a punch to overcome the squeeze of surface tension and form bubbles. This is boiling. But there's a loophole, and it's a really dangerous one. This loophole, this is the key to our whole mystery. The culprit behind our exploding water has a name, superheating. This is the phenomenon that sets the trap, turning a simple, innocent cup of water into a tiny, unstable bomb that's just waiting to go off. Superheating it's a really bizarre state of matter. The water is actually hotter than its own boiling point, but it's not showing any of the signs. It's completely, deceptively calm. There's no bubbling at all. All of that energy that should be turning into steam is just trapped inside the liquid, waiting for a trigger. So the big question is, why does this happen in a microwave and not on your stove? And this right here shows the crucial difference. See, on a stove, the heat comes from the bottom, which creates hot spots. Plus, any pot has all these tiny scratches and imperfections on the surface that act as starting points. We call them nucleation sites, and they're perfect for bubbles to form. But in a microwave, the heating is super even, and a smooth ceramic mug, it offers basically no starting points for bubbles. So the water just gets hotter and hotter and hotter, way past its boiling point with nowhere for that energy to go. The trap is officially set. So once that water is in that superheated state, it's hotter than boiling, but there's no way for it to release that energy, it is incredibly unstable. All it takes is one tiny disturbance to spring the trap and unleash all of that pent-up energy in an instant. So let's walk through this chain reaction. Okay, the water is superheated, totally unstable. Then you introduce the trigger, say a spoonful of instant coffee. Well, the thousands of tiny, rough surfaces on all those little coffee granules suddenly provide millions of places for bubbles to form all at once. This causes a flash boil. All that trapped energy converts to steam instantly, and it has nowhere to go but up, erupting violently out of the cup. So, mystery solved. Superheating happens because of that perfectly even heating in a perfectly smooth container. Now for the really important part. How do we prevent this from happening in our own kitchens? How do we stay safe? Luckily, it's pretty simple. Here are 3 easy ways to stay safe. First, just add your sugar or coffee before you heat the water. Their surfaces will give the bubbles a place to form as it heats up. Second, you can leave a wooden stirrer or even a chopstick in the cup. The porous surface of the wood is perfect for bubble formation. And finally, just don't overheat it. Heat the water in shorter bursts, maybe a minute at a time, and stir in between. All of these tricks just give the bubbles a place to form safely, preventing that dangerous energy from getting trapped. And that's really the bottom line here. This isn't just some fun science factoid. Understanding what superheating is and how it works is a really practical way to avoid a huge mess or even a pretty serious burn. It's a perfect example of how the physics all around us can have very real-world consequences. And with that, the case of the exploding water is officially closed. It really makes you wonder, what other hidden physics is at play in our daily lives and things we do every single day? Stay curious out there, and thanks for joining me.